A question that has been asked a couple of times is, when do you know when to use a chart to set up these problems? My suggestion to you is that you use a chart as often as you can, and usually you're going to use a chart when you're comparing things. Take an example. On page 286, number 39, it talks about a pottery stand at a fair, and how they sold some pottery at an original price, and then later they decreased it by $2, and how they did a total selling of 90 pieces that took in $721. Now, what you're comparing in this case is the original price of the pottery versus the new price of the pottery. You see this a lot in rate times time equals distance problems. You compare going one way versus the other way. And you also see this a lot in mixture problems, when you're putting one thing together with another object. If we go back to problem number 39, what we're comparing is the original priced pottery versus the new priced pottery. And what we know about this is we know how much, or the price per pot or per pottery. And what we also kind of know is the number sold as a total. We'll find out individually. We also know, or want to know, how a total cost being brought in. Now, the original pottery sold for $9.50. The new pottery was sold for $2 less. So that would mean it would be $9.50 each. Now, we don't exactly know how many original were sold, so that will be X. That will be the number of original sold. And our Y is the number, we'll call it the new sold. We know that the total number of potteries being sold was 90. So down here kind of represents the total of them. And we do know that they brought in a total of $721. So again, total amount of money. Now, if we think about it, if they sold one pottery at $9.50, the total cost would be $9.50. If it was they sold two potteries, it would be $19, and so forth. And what we do with this is we multiply those two together to give us a total pricing of what the original was selling for. So $9.50 times X. The same can happen with the new. $7.50 times Y. Now, what you will see here is a few different things. I get one equation by adding the number sold of the old, or the original, with the new, equaling 90. And I also get another equation coming from the total price. So you'll see we end up with two equations to set up our system. Now, one way to solve this would be to we could do substitution, or we could do elimination. I'm going to choose by doing this one by substitution. I'll bring the Y over to one side, and I'll take this and I'll plug it in for the X. 9.5 minus times quantity 90 minus Y plus 7.5Y equals 721. 9.5 times 90 is 855 minus 9.5y plus 7.5y equals 721. Combine like terms, subtract, I get negative 2.5y equals negative 134. Sorry, this should be that should really be negative 2y equals negative 134. And if I divide negative 134 divided by 2, y equals 67. And since y represents the number sold at the discounted price, this was the number sold at $7.50, and I can plug it into one of my equations, x plus y equals 90, to figure out how many they sold at the original price, which would be 23 at $9.50. So again, you really want to try to use those charts as much as you can in order when you're comparing things, comparing different topics of each category.